Computer. Okay. All right. I shouldn't have to share this again, right? Let me make sure that's still sharing. Okay. All right. Welcome everybody to the Marine Amateur Radio Club. This is our advanced topics week. So today we're going to be talking about APRS, gateways and services. Can everybody hear me okay?
Yep.
And everybody can see the monitors swelling up? Okay. So what's APRS? We had a discussion about APRS back in 2020 in the height of the pandemic, where we went through where APRS came from. We talked about Bob Berninga, who was the guy who developed the concept of APRS, and we talked about how it has been called many things, but APRS officially stands for Automatic Packet Reporting System. It's automatic in that it operates without the control operator doing anything. So you're still a control operator for your system, but you don't have to sit there and poke at it all the time to make it do something. It operates fully automatically. It's packet based. It uses packet radio technology. It is not compatible with the packet radio stuff that we talked about a couple of weeks ago. This is using the AX25 packet system, but not the same mechanisms that packet radio uses. The routing doesn't work the same. We'll talk about that. Reporting, it's used for disseminating information and system. It is not a standalone thing. It's multiple radios, multiple computers, networks, and lots of different things to go together to make this thing actually productive and useful. There's a picture here of Bob Berninga. Bob passed away last year. He had actually come out to Utah several times. He was a faculty member at the U.S. Naval Academy in Annapolis, and part of his work out there was working with small satellites, and he would come out to Utah routinely to attend the small satellite conference up in Logan. And that's where I got to meet him for the first time and talk with him about ham radio, because whenever he would come, he would always do a presentation on APRS. Dan, you had a question?
If you go to the APRS.FI website,
yes,
and put this call sign in, you can see where in heaven he's at.
Oh, I did not know that. Maybe we'll try that when we have a chance to do that. Okay, so Bob passed away, like I say, and he's now silent key. So, but APRS lives on. So what does it do? We talked in our previous presentation about what APRS is, how it works, what equipment you need to make it work, and things like that. We're not going to talk about that tonight, since we already have talked about that. That presentation is online on the website. The link is here. If you don't know it, it was given in May of 2020. The video of that presentation is also online. So if you need to refer back to that, feel free to click on that when you look at this slide. And when you see this on the website, you'll be able to click on that and go watch that presentation. This presentation about doing something with APRS, including some of the less common things that we want to do with APRS. So the key thing is APRS is a tactical, real-time information distribution system. So what does that actually mean? Lots of people get hung up on position reports. APRS is not about position reports, although APRS packets do include position information. APRS can be used to track you and show people where you are. And there you'll see people sometimes in their mail signature, they'll say, want to know where I am? Click on this find you link and you'll find where I'm at. And that's because they're running APRS. But it can be used for a lot of other things. One of the key things is for local information, what repeaters are commonly used, when the nets are, that kind of thing. And I noticed a couple of weeks ago when I was putting this presentation together, we used to have a lot of repeater objects on the map here in the valley, and we don't anymore. And I don't know if somebody quit publishing them or what happened, but I'm going to work on getting a permanent APRS station up. And when I do that, I will publish at least our repeaters and our nets so that those could be seen on the APRS. Hey, Kevin. Not Kevin. Yes, Kevin, right? Dan, sorry. The other Dan, Dan 2. Okay. So another thing that can be used with the position information is objects on the map. And like I was just saying, I haven't seen the repeater objects on the map anymore, but you can put objects on the map. You can move them around on the map, and they can be used for tactical information. Like if you're doing a bike race or something like that, you're supporting a bike race, you can mark on the map where the riders are, where groups of riders are, things like that. So you can mark like the head of the first rider and the last rider. And that way people who are tracking that can visually see on the course what's going on, where people are. So that can be very useful. We can send short text messages from operator to operator and other messaging, which we're going to talk about in more detail in a minute, to and from non-amateur radio operators. And then another use that is common with APRS is delivering telemetry. A lot of times this is things like weather information. A lot of people with a weather station will hook their weather station up to their APRS system and transmit out their weather information. We'll take a look at that in a little while. But the other things that I've seen this used for are for sensors like flood meters. I've seen flood meters on APRS where this might be a position or a place that's far away from internet service or far away from phone service or anything like that. But you can slap an APRS radio in there, and as long as it can reach a digipeater, it is able to get that signal out and present that water depth information or tide information. Or I haven't seen like a snow depth meter, but we could sure use something like that around here. That would be pretty cool.
The guys that work out, they're big hunters and stuff like that, and I don't know what app they go out to. They're looking at it every day just to see how much the snowpack is.
Yeah.
You know?
Well, I know I've gone to like the ski resorts and looked at their snow cams and things like that just to see how deep the snow is up there. But it would be kind of cool to have that automatically transmitted out via telemetry from an APRS system. It's also been used on high altitude balloons to help track where they are. We'll talk about that. And also satellites as well have APRS on them sometimes. So let's talk about tactical. So we know what strategic information is. That's like information that's in a large area or global, right? If you're trying to reach out to radio operators on your HF system, you might want to get on like a DX cluster and find out when the bands are open or who's out there. That's kind of strategic information. It's global, right? APRS is more tactile. It's local. It's geared for what's happening where you are. So it has the ability to send data over a wide area, but the primary purpose is local information for tactical purposes. So one of the key things about APRS, one of the things that Bob would always say is turn on your radio and leave it on for a half an hour. And then within a half an hour, you should know where other operators are. You should know where the repeaters are. You should know when the nets are. You should know all of this kinds of information because it is sent out periodically over APRS. That does depend on people actually publishing that information, which, we'll talk about that. APRS uses a flood fill algorithm. So remember when we were talking about packet radio, we talked about how you can route packets from like your machine to Dan's machine to Neil's machine. If I couldn't see Neil directly, I could maybe reach him through Dan. Well, APRS doesn't work that way. It's not station to station. It's like, I'm going to put this packet out there and everybody who can receive it will receive it. And digipeaters that receive it will take it and retransmit it and they'll send it out farther. So you think of it like, if you've ever used like paint programs where you click the little bucket and you click on an open field and it fills that area with paint, that's kind of how APRS works, right? In APRS, it is using packet radio packets, but instead of putting a station ID in that destination packet or destination address field, you have a special code that is used to identify the type of radio that you're using or the type of TNC that you're using. So There's a whole list of those out there, and I'm not sure who's maintaining that list these days now that Bob is no longer with us, but it is being maintained, I know. So as new devices that use APRS come into existence, people have been extending that list.
So distributors decrement that, right? Like if I send wide 2-2.
Yeah, we're going to talk about the wide routing right here. So the new wide NN routing was implemented in 2004. So when we call it new, keep in mind it's 18 years old already. All right. Originally, when people were playing around with APRS, they were using a routing mechanism called relay. And basically you would say relay on your packet and digipeaters would pick that up. And if it said relay, they would relay it. And if it didn't say relay, they wouldn't. And so, that worked great when there were only like 5 people using APRS. The problem with APRS is there is a limited amount of bandwidth. So the more stations you get using APRS, the more congested that frequency gets. There's a single national frequency, a nationwide frequency that's used for APRS. It's always the same everywhere in the United States. It's the same. Other countries also have their own, like Europe it's a different frequency from the US one, but it's the same frequency over all of Europe. So what you want to do is you want to not push your information via RF all over the whole country, right? Because who in New York is going to care that we have a net on Sunday night? Well, probably nobody, right? So the way that we get around that is we use a field in the APRS packet called the path field. And the typical path that is used most of the time is this, what we call wide 2-2. So this is the wide N-N routing. You can plug in a number for N in that path. Wide 2-2 basically says, I want it to go through 2 digipeaters or 2 hops away from where I'm at. So if I'm here in Salt Lake or in Murray and I send the packet out and a digipeter in, say, up on Farnsworth, up on whatever the peak is over there, not Farnsworth, but the other one, there's a digipeter up there, and it receives it and it sends it out. Now it may get as far as Wendover. If there's another digipeter in Wendover, he's still got one more hop left. So he's going to send it again, and it may get as far as like Elko. So my local packet might get as far away as Elko or Rock Springs or somewhere, right?
And so the more hops you do,
The farther out it spreads, right?
that's cool.
But each time it goes through a digipeter, it decrements this number. So once they're all gone, it doesn't get sent anymore. So other digipeters farther out won't pass it on. But you can actually go quite a ways with a packet with just 2 hops, especially out here in the Western US where we put things on mountains. Dan.
So let's say you have a digipeter on Farnsworth and Insight. They both receive a white 2-2 packet. They're both going to send that.
Yep.
So you can have, this isn't just a digipeter to digipeter.
No.
It truly is a broadcast.
It's a flood fill, right? Yeah. So each digipeter is going to send it out again, and other digipeters will receive it. Now, digipeters also keep track of what they've received recently, and they don't, if they hear a packet twice, they don't send it twice, right? They'll throw away the duplicate. But yeah, that can happen, right? So it can go, that same packet that I sent from here in Murray, not only is it going to go all the way to Elko and Rock Springs and, freaking West Yellowstone and Las Vegas, it's going to go to all of those, right? And also what can happen along the way is there are systems that are called iGates or internet gateways. And what those systems do is they will listen for packets going by. And if they receive a packet, they will put it on an internet network, I guess you'd call it, and send it into this, what's called the APRS IS or APRS internet system. And from there, obviously it can go all over the world, but it's not consuming RF when it does that. One of the things that we worry about in APRS is that we're using up all of that RF bandwidth, right? So here in Utah, you might get by with a wide 1.1 and be able to cover your local area just perfectly fine. But if you were like in Delaware, where the ground is, where the place is flat, right? There's like the highest mountain is like 200 feet above sea level. So mountain, yeah. It was like 200 feet above sea level. So your wide 2-2 path out there might only get you 60 miles, right? Which is why the standard is wide 2-2. Now, are there occasions where you would want to use something other than 2-2? Yeah, you might want to use 3-3. If you're in a very rural area with limited digipeater access. So say you're out in Duchesne and there's only one digipeater you can reach. Maybe you go with 3-3 so that you make sure you get all the way back to Salt Lake, if that's something that you need to do. But remember, APRS is for local information. So do you need to get all the way to Salt Lake on RF? You probably don't with APRS. There's also the facility of using geographically limited paths, and I've seen this done in cases where you're doing an event where you want to keep it localized within your state or within your county area or something like that. And so you can specify a path, and local digipeaters know about these particular specialized paths. So the statewide ones are typically the 2-letter state code followed by an N-N valuation, just like the wide to N-N. It's going to be like UT 2-2 for Utah. And then it will try to go through 2 digipeaters, but it won't go into, like, if there was a digipeater in Nevada, that'll just ignore it because it's not a NV, right? Also, each digipeater is going to put in its identifier so you know where the packets have gone and how they got to you, which is kind of cool. Okay. So other special cases, APRS, there's actually an APRS station on the International Space Station. So right now in orbit, there is a Kenwood TM D710 up there that is configured for APRS, and it is sitting there listening. Now it's on a different frequency from the national frequency, so you can actually tune into that frequency, and if you know when the ISS is passing over, you can actually hit it with an APRS packet. And of course, you use the special path of ARISS because you don't want it going anywhere other than the space station and back down, right? You don't want other digipeaters picking that up, because keep in mind the space station is 300 miles up. It's going to see a very large footprint. So no point in having it digipeated again once it comes down from that, right? You can also use temp for temporary events. These are like, say you're at a place where you are down in a gully or something, and you want your APRS traffic to get out, you can put a temporary digipeater up at the top of that gully and set it up with a temp N-N pathing, and then your packets will hit that from down in the gully, but they won't be picked up by anything else. Your digipeater up on the top, your temporary one, will forward it out. You'll also see people use like wide 1.1 comma wide 2.2. And so what'll happen there is it's going to look for a digipeater first that's just a single hop, and that'll eat that wide 1-1 path component. And then when it sends it out, it'll use the wide 2-2, and it'll go out normally from there. There's also a lot of times you will use no path at all. So if you're running an aerial station, like you've got a radio in an airplane or in a balloon or something like that, you don't want that to be digipeated because your balloon is at 80,000 feet. It's already got a very large footprint of what it can talk to. And you may use a different frequency from the national frequency for something like a balloon. But they specifically recommend no path at all for aerial stations because they can see a very far distance from where they are. And so you don't need them to be digipeated.
Can you do something like no path? Are you just setting that by 0 or?
You're just leaving it blank, right? So you're leaving it completely empty. There's a place in all the APRS software you can specify the path. We'll talk about that when I go do the demo coming up here. But yeah, you would just leave that blank. And then there's also a facility to run APRS on HF on 30 meters. And HF stations should never digipede because remember, HF has a very long propagation. So you don't want any digipeating happening there. You might have an HF station talking to another HF APRS station on the other side of the planet or the other side of the continent. You don't need it also being digipeated once that happens. Why suck up that RF bandwidth if you don't have to? Also, you got to think about on HF, you're probably running at 300 baud at the most. And so your available bandwidth is cut in a quarter right there. And if you think about it, APRS, whenever I send an APRS packet out, I'm going to send it, and then the digipeater is going to receive it and send it again. So every packet that I send is going to get sent probably twice or more, right? So keep that in mind as well. All right, let's talk about these internet gateways. There's a whole backbone on the internet for carrying APRS traffic, and it's used so that people who are interested in watching the traffic can do it even without a radio. And if you're interested in watching the traffic somewhere that's not local to you, you can do that with the internet-based stuff. iGates, they are used, they're like a special kind of digipeater. They receive the packet and move it into the internet system. And they can also, if they're bidirectional iGates, they can receive traffic from the internet and send it out on RF. Now, there are some rules that apply to that. For example, typically, iGates will not send a packet out to a specific address or a specific call sign if they haven't heard that call sign on RF already. But because APRS is a beaconing type system where every 10 minutes it's kicking out a packet, they probably, if you've got your radio on, they probably heard, an iGate has probably heard you and knows where you are. So we'll talk about how that actually works in a few minutes. And then other people have written software that sits on that network and listens for things and does stuff based on what it hears. So we're going to talk about some of those. All right, first one we're going to talk about is SMS gate. Everybody's familiar with SMS, right? Text messaging on your cell phone. There's actually a gateway that will sit on APRS and listen for packets that are addressed to SMS gate and will send them to someone's phone number via text message. And it's bidirectional. So when they receive a text message from you and they reply to it, SMS gate will send an APRS message back to you. Typically, if it's been iGated through, it will try to come back to you through that same iGate and back on RF. So pre-registration is not required to do this, but if you do register, you get some special features like aliases and stuff so that you don't have to actually put people's phone numbers out over the air all the time. There's no charge for this. The guys that run these gateways, they have decided that any costs that are being borne by their SMS traffic, they're going to eat that cost. And it works in 7 different countries, including the USA. So you would compose an APRS message to SMS gate, and then in the body of the message, you would put @ and then the phone number that you want it to go to, complete with the country code, which in the US is 1. So you have 1 area code and then the phone number, and then the text of your message. We're gonna go ahead and do a quick demo. Now I'm gonna make sure that this actually is gonna come through okay. So let me make sure, I'm gonna get back in here. Okay. So I'm gonna,
Can you go back to the previous slide?
Yeah.
Okay, so you're doing the at number and then the message.
Yep.
Yeah,
okay. So what we're gonna do is what I've got running here. This is some APRS software called Yak, yet another APRS client. And let me see if I can't get this shared. I'm going to stop sharing this. And I'm going to share you this window. Okay. Make sure that gets out there. Okay. So what you can see here, I've got this APRS client called Yak, and I've got it running on my laptop here. This Yak is written in Java, so it's very portable. It's easy to use it with whatever OS you happen to be comfortable with, whether it's the Mac or Windows or Linux or whatever. And just real quick, I'm going to jump in here to the configuration and show you right here. It's not actually not showing up on the share. Let me fix that. If I stop the share here and I share, if I share the whole screen. Okay, there we go. So you can see here, I actually have this going just over the internet. So I could have brought in my radio and my my signal link and hooked everything up so that I could, drug an antenna outside and put it up and done this over RF. But because I figured, this class isn't really about that part of it. It's about what you can actually do with it. I can do this all on the internet. So what I'm using right now, the way Yak works is you have a port configured, and that port is a way for the client, the APRS client, to talk APRS. So your port might be a radio port, or it might be, as in this case, an APRS IS port. Okay. So this is connecting to an APRS server called noam North America.aprs2.net. And the server port is 14580. I've got my call sign here and my APRS IS password. If you don't know what your APRS IS password is, there are ways to get it. And all you have to do is probably do a quick Google search. But if you ever want to do this and you don't know what yours is, you can ask me and I can get it for you. It's calculated based on what your call sign is. The other thing I have on here is an APRS filter. So I'm not receiving all of the APRS traffic for the whole world. I've given it a coordinate and told it to give me 100 kilometers around that. So I'm only going to see APRS traffic that's happening within 100 kilometers of my location. And the location that I have given it is the location of my QTH. So you'll see that that's where this little house is right here. So you can see my call sign and my SSID, which is -1, and you'll see stations start popping in as it receives packets from the internet in order to know where people are and where things are. So here's a digipeater up here. This is one of the digipeaters up on the mountain up there. And this is showing what it can see, right? So we can see these are stations that are coming in via RF that it's able to see. These are additional digipeaters. And then these are some actual people that are out there. And you'll see that there's a little age tag on this that kind of shows how long it's been since the last packet was received from that. So that's kind of cool. But what we wanted to talk about was SMS gate. And so what I'm going to do is I'm going to send a message to SMS GTE. And the message I'm going to send is, let me pop up. Not that. I'm going to do chat with station. And I'm gonna set this to SMSGTE. So it's giving me a little window here where I can type things at SMSGTE and you'll see his responses come back in here. So one of the things I'm gonna send is at 1-801-809-6269. That's my cell phone number. Hello there. And if we wait a second, I just received a text message on my phone.
What's the message size?
It's pretty small. It's like, it's less than a Twitter tweet size, right? You want to keep it as small as possible because you can use longer messages, but keep in mind, every character that you send is sucking up some of that RF bandwidth. And everybody's got to be out there, right? So you want to keep it really short. People have used this typically for, honey, I made it to wherever, the top of the mountain or whatever, right?
This is like a really nice, clever in between, or what those like Garmin satellite in reach, whatever.
Yeah.
Right? So that's like the super extreme case. But here, like you're at the edge of, like I can reach something with my radio.
Right, but I might not have cell service there. I can still get a text message to whoever is on the other end, right? So I'm gonna go ahead and send a reply. And all I have to do is say in my reply, I'm gonna say at KD 7 ZWV -1 it worked. I'm sending that text to the same phone number that I received it from. And you'll see there it is. And it came in from my phone number and it says it worked. Huzzah.
So this is broadcast everywhere, but is there anything that filters?
No.
Did you just reply to that, or what did you have to?
I actually replied, I put in at and my call sign and SSID,
Oh.
which was
yeah,
in the message that I received on the phone. So
Yeah, so you'd have to have the client ID.
yeah, in fact, I can go over here. Where is it? Let's do this. And if I zip over to, where are you? Let me just go back to this guy and do it here. So Mighty Text is a app that I have on my phone that allows me to send messages, text messages from my computer through my phone. So you can see this is what the message looked like when I received it. It said at KD7ZWV-1, hello there. So it came from this 201, which is a New York area code, I think.
North Jersey.
So 201-762-0073. And then I replied back to it and said it worked. And that came back to me on APRS over here. Now, if I was using RF and there was an iGate in the way that was listening for this, the iGate would have received my initial packet, realized who I was and where I was, and that I was local to it because my position information is included in that, right? And sent that over APRS-IS, just like this Yak client did. SMS Gate would have seen it, sent the reply back, and then the iGate would have seen the reply go out over APRS-IS to everybody and would have said, oh, I know that guy, KD7ZWV-1, I've seen him. I'll squirt it out on my RF connection and his radio will pick it up. So it's not super robust. Okay, it's kind of fragile, right? But when it works very well. So
Feels a lot like very primitive, edge routing.
this stuff,
Yeah.
APRS was developed in the 80s. Okay. It's been 40 years. It still works. And it actually works pretty well. Okay, let's go back in here. Let's see. So the next one, now I've lost my full screenedness. Oh, well. We'll just do this. Okay. So the next one that we're going to talk about is email. So just like for SMS, there's a gateway out there that is listening for packets that will happily send it to an email address for you. Okay. And the system is called email, but the email one has been shut down. So the original gateway, they shut it down in 2019, but there's a new implementation called email-2. So if you send a message to email-2, where the message body is an email address and some message text, it will get sent through. We'll talk. So one of the things about that is that it's not easily bidirectional. And the guy who wrote this email gateway, he was very concerned about making sure that people knew that they were actually sending stuff over the radio when they were sending an email back to this. So it's a little complicated to get things to go back and forth. So if you want to, you can set up a shortcut. And again, what you do is you set this up with the email server first, and then for starters, you don't have to send somebody's actual email address over RF all the time. You can just use the shortcut. And you can also, it can do things like maintain information about you and give you that information back. So one of the things that they have is if you tell it a shortcut for your own email address, then it can send emails back and forth to you. It'll know how to associate you with that call sign, right? And then if you say L as the message, it will give you a list of what shortcuts you have created. And if you say R, you can remove one of those shortcuts. So if you want to get rid of a shortcut, you can pass that through to it. And it keeps track of that for you. So bidirectional email is possible, but you can't just reply to an email that you received. Like I just replied to the text message that I got. I can't just reply to the email. I have to send an email to the same address that I received the email from the APRS station. And I have to specify that machine's email address in the to field of my email. So in my case, when I was playing around with this, it was coming from APRS email 2 at ae5pl.net. The subject of the message has to be the call sign and SSID of the station that I'm trying to reply to, followed by a colon, and then followed by the message text that I want to send. So everything has to go in the subject line. The contents of the body of the message also has to include the text user ID colon, and then the name of the shortcut that was used to send the message to me, followed by another colon. So it's a little complicated. It's a little weird. One thing about email 2 is if I reply to it and I send, so say I send an email back to Dan's APRS station and he's not online, the email server will hold on to it for up to 24 hours. And so when he does get back online, he can send a message to email 2 that says get, and it will forward him any of the messages that it has received over the last 24 hours. So we're going to go ahead and play with that a little bit, give that a try. So let's go back to our APRS. We're going to do a chat with station, and we will chat with email-2. So I'm just going to say me L to see the list of shortcuts that I already have with this guy. And it says, I sent an email to this email address. Well, that's great. Let's see what happened with that. Let me fix this a little bit. I don't want to be paging all over the place. I'm gonna go ahead and bring up my Gmail. And here you can see, here's an email that I got showing what my shortcuts are. So I've got Dan defined with Dan's email address, and I've got me defined with my email address. So if I wanted to send an email to Dan, I send a message to Dan. This is via APRS and email gateway. And it now has sent that to Dan. And Dan, if you check your email, you will have received something.
Yep.
Now,
This is by APRS and email gateway.
and it's specifically, I'll go ahead and send one to myself so that we can pull it up on the screen here. I'll send it to me, another test message. It does tell you not to reply because you can't just reply, right? So if we look at this, this is what the message looks like, right? Let's close this up a little. So you see it came from KD7ZWV to me. And if you actually expand that out, you see that that was APRS email 2 at ae5pl.net. The subject is everything that I sent. The call sign that it came from and the message that was sent, another text message, right? And then it says specifically, do not reply. And then it gives you like a find you link and some links to track people, figure out where it came from. And it says who it was received by and click on this link for more information. We're not going to do that right now, but I can, if I do reply, what I have to actually do is I can't just reply, right? I have to change the subject. So the subject needs to be the call sign, colon, and then my reply message. And again, the entire message has to live in that subject line, right? But then in the body, I have to say user ID colon, and my shortcut for my email was me. So I have to have me colon. If Dan was going to reply to me, he would have to say user ID colon Dan colon, and he would have to know already that Dan was the shortcut I had created for him. So you do need to kind of set this up before you start using it. And then if I send this,
That's clever though, because then you can just grab the first line and toss the rest of the body.
Right.
And then you don't have to worry about the mail client.
see if that actually worked. There it is. So you saw that come in over APRS and it says it was from me. And the text says my reply message. Dan, do you want to try to send me one? So yeah, you have to kind of set it up a little bit beforehand. And the people that you're going to be sending messages to, you need to let them know how to do it. And at the same time, you should brief them, don't put anything on there that you don't want everybody in the world to see. Don't do anything of any prurient nature that would be illegal for amateur radio and that kind of stuff, right? So you got to make sure you're not doing things illegally.
Yeah, just so everybody knows, I have the utility packets heard from KD7 ZWB-1, and everything that you've done tonight.
You've been watching. Yeah.
Yeah, and when something new comes up.
There it is.
There it is.
Yep.
Yeah.
Yeah, so you can actually watch raw packets too. I don't have that display up, but you can, it's promiscuous, right? I can see everything because if I'm listening to that network, I can hear anything that's happening on the RF. It's being broadcast, right? Or I know we're not supposed to really broadcast, but you get the idea. All right, we'll wait and see if Dan gets a message back to me.
I have an issue with Gmail. It will not let me modify the subject line.
Oh, you have to go, like when you go to reply, if you look here, see the little thing here there's a pop-up and then you can have edit subject.
What did you click on?
So if you hit reply, right,
Uh,
and then hit on this little drop down here, then you can go to edit subject. Yeah, I hate the web interface for Gmail. It's really terrible.
Okay, so what do I need to put there? Get rid of the re?
Get rid of the re and just start it with KD7 ZWB-1 : and then whatever you want to say.
Okay.
And we'll see what we get back.
Okay, do I need to put anything in the body?
Yes, you have to put user ID : Dan :
User ID,
Dan :
anything else?
Nope, doesn't matter. Anything else is going to be ignored as long as that string, and that string doesn't have to be at the beginning of the message body. It can be anywhere in the body. So it doesn't care as long as it sees that in the body. That's all it cares about.
Yeah, I send it.
All right, it takes it a minute. There it is. Hello, big boy. Shit. Thought this was Dan I was talking to, not Ragnar. But okay. Sorry, Ragnar. All right, so let's go back to what's that? So we'll go back to our thing here. All right, so another one is the who is service. And there's actually two. There's who-is and there's who-15. Because if you look at this who-is, it looks kind of like a call sign and a dash and an SSID. But some old RF clients, like the old DOS-based APRS client, will not allow you to put alphanumeric characters in place of the SSID. So the guy actually has written this so that it will respond on both who-is and who-15. But if you're familiar with like QRZ and you've looked up a call sign for somebody that you heard on the air, you can do that with APRS. So even if you're not online or near a computer or don't, phone battery's dead or whatever, you can send a message to who is with the call sign in the message body, and you'll get back a message with their license class, name, state, and country. So the 15 here, I just mentioned that some software doesn't support non-numeric SSIDs. If you prefix the call sign with F, you'll get all the information that they know about that. And this actually works for non-US call signs as well, if they are known to, or if there's a way for them to be able to maintain that database. So we'll go ahead and we'll do one. So I'm going to do a message, chat with station. We're going to chat with who is. Pull this down. And for fun, we'll say, what's your call sign? K7LDN. I'm just going to say K7LDN and send that. When I get back, you're a general. Your name is Gabriel Floyd. You live in Utah in the United States. Pretty slick. Hello. Why did that pop up? That's the general generic messages window, which we don't really care about. If I was to do something like F, and I'll do KD7 ZWB, which is my call sign, it's going to give me a full dump on that. So there's my name, technician class, my address, Murray, Utah, United States. And if I put in somebody like, gracious, go away. I want you to stay out of my face.
It's just enough delay that you've already.
Right? I'm already started to do something else. And it's like, oh, hey, did you see this? This was addressed to you. You should see this. Okay, so if I send one, let's see, who was the one that I used?
You're
doing the full screen.
Yeah, I'm doing the whole screen. So, yep. Let's see if we do something. Who is, does anybody know, gracious? What are you sending me? Give me all kinds of information that I don't want. Does anybody know like a Great Britain call sign or a German call sign or something like that? Just off the top of your head, somebody that you've talked to.
Yeah, just 2 seconds, I can't remember.
Look at your log.
I have.
How about VK4KU?
LD0FI, LB0FI. So we look that up. Morten Marius Waken from Norway. Now, I don't know what happens if we do a full on him. LB0FI. So we got his address. Oklevin 337 in Halden in Norway. So that's kind of cool. It's an interesting system that's out there. And obviously it can't look up everybody because some countries don't publish that information. But if it can get the information, it will try to present it to you. So I think on the back end, it actually uses some database that's already existent out there, and I don't remember which one it's using, but yeah, it's looked up every call sign I've thrown at it and been able to come up with at least a name. So it's kind of cool. All right, let's go back. Well, that was our demo for who is. So another one is CQ server. So what CQ server does is it lets you register with a particular topic, and then anything that anybody sends to that topic will also get sent to you. You can use this to, once you've made contact with somebody, to start up station-to-station conversations, right? The way that it works is you send a message to CQ server, and the body is CQ and the group name that you want, and then your message. And so what it'll do when you do this is it will, to anybody else who's registered as that group name, it will send your message to them, right? And then anybody else who sends a message to CQ group name, whatever that group name is, you'll get a copy of it because you're part of the group now. You can send it a special command, U group name, to unsubscribe from a group if you decided you no longer want to see messages from that. Or you can wait 12 hours without doing anything, and it will automatically unsubscribe you. You can send it a question mark. It'll list all the groups that it knows. You can send it a question mark and a group name, and it will show you how many people are already in that group, which is kind of cool. It won't send you the list of who they are, but it'll tell you how many there are. And then L by itself will show groups you're currently watching, right? So it's kind of cool, and it's a clever idea, but of course, as all things that are not quite cool enough are, somebody has taken it to the next level. So there's another one called AN server, or announcement server. This was developed because there were some perceived deficiencies in CQ server. One of the deficiencies being the CQ server doesn't recognize tactical call signs. So if you're using a tactical call sign on your APRS configuration, CQ server just ignores you completely. And the CQ server also requires that you send a message to a group when you join it. So you can't quietly on the side join a group and just listen. You have to actually say something, which is, some people care about that. Other people are like, what the heck? If I'm joining the group, I might as well say something. And it still, answer server or announcement server still supports that. So there are some additional commands that it has in addition to the question mark and the U that CQ server knows about. You can say D, and it will show groups with a description. If you say D group, it'll show you just the description of that group. Or actually it will set. So if you say D, some group and some text, it will set the description for that group to what you sent. L will list groups you're a member of. J will join a group quietly. So that basically says, I want to subscribe to this group, but I don't want to actually send a message to it right now, which is fine. And then K will quietly tell it, hey, I'm still here listening. so don't time me out. So you can send that, every 9 hours and you'll stay on the group forever, right? It also has the concept of group owners or initiators. The first person who sent a message to a group will show up as the owner of the group, which I don't know how useful that is, but it's what it is.
Could you, after this section, I got a question for you.
Yeah.
Continue on.
Okay, so I looked on Monday night when I was doing some work on this presentation, and at that time there were 438 groups live on a announcement server. Some of the more interesting sounding ones that I saw, and I spelled satellite wrong, AMSAT, APRS Droid. If you guys are not familiar with APRS Droid, and if you have an Android phone, APRS Droid is the software to do APRS on your phone. If you're using an iPhone, I'm sorry, but there is a software package, APRS Fi, that will run on the iPhone. It will do a lot of things that APRS Droid will do.
Yeah, it's really awesome. Open screen maps. So
Yeah.
You can take your position report.
Even if you're not online, right? If you don't have cell coverage, you can still do stuff, right?
And that's where my interest in APRS Grid came from, is not in this connected iGate thing, but from simplex local.
Mhm. And that's what APRS is for, remember, local tactical information, right? Balloon is a group for high altitude balloon alerts. ISS is a group for the International Space Station. JOTA for Jamboree on the Air. Sky Test for Skywarn test messages. SOTA for summits on the air. There's a lot of them, right? I'm not gonna ask it for the list right now because, like I said, there were 438 entries. There were a whole gob of them. So, but you'll look and you'll see, oh, here's a bunch of groups with just one member in it. Jump in there, strike up a conversation, start talking to somebody, right? Let's go ahead and do a demo here.
I feel like I'm going through the stages of grief learning about this. It's mildly perverse that someone's trying to make like IRC or BBS.
Right?
APRS, and like,
BBS is over packet radio. That used to be a big thing back in the 80s, right? And even the 90s. It's coming back. People want to still do that. It's totally cool. And the technology still works, right? So if we do ANSRVR, now remember there was actually I was going to do it in a chat with station. ANSRVR. Okay. So I was going to do a remember the CQ server has a question mark that will give you back all the groups, right? AN server, if you send it a question mark, it's going to come back and say, yeah, we turned that off. We're not allowing that right now. Should come back with that in a minute. Send it to me already. Nope. And maybe it's crashed. Try sending it. Oh, there we go. Yeah, so active groups query is currently disabled. But remember that what was it? D you could send. D will show groups with descriptions, right? So yeah, you could do that. We're actually going to just send a message to one of these groups that I mentioned here. We'll send it to what should we send it to? Let's send it to, I think there's just an APRS group. I have actually, where do I have that? I actually have that. Where am I? Here's a list. So this is the list that I pulled down on Monday. So we could look for something on here that looks likely to have somebody in it. Anchorage Aries members, please join. There's a group called Anyone. ARRL. You see, most of these have just one person in them. When you see this part of the list that goes back with also, these are groups that don't have a description. So they're just a list of groups that don't actually have a description. So presumably the people on them know what they're for. But let's see. So Balloon has 7 people on it. We actually have a chance of getting something back on that. Let's see who's likely to be around.
Do they have like a weather report? Like,
Well, there is a thing that does that. We'll talk about that in a minute. Well, I'm actually not going to do a demo on that as I think about it. There's just too much noise likely to happen and too much risk of not actually getting anybody. So we'll skip that for now. Maybe we can play with that later if we have time. So WXBot and WXYO. So WeatherBot gives you your current and future weather conditions. So the way so there's 2 of them. There's WXBot and there's WXYO. WXBot only knows about U.S. National Weather Service stuff. Okay. WXYO actually can look up non-U.S. stuff. It's actually based in Romania, but it can look up stuff from pretty much anywhere in Europe, I believe. So WXBot, there's 3 things you can ask it. You can ask it where, when, or what. So your where can be some way of it knowing what, where you're interested in. You can send it a city and state. You can send it a call sign, and if it has seen that call sign, seen a position report for that call sign, a beacon, it will figure out where that is and figure out what's close by it and send you a weather report for that place. You can send it likewise an APRS object. Objects have a position associated with them, so it'll associate with that and figure out where it was. You can send it a latitude and longitude in decimal degrees, so not degrees, minutes, and seconds, not degrees, minutes, decimal, fractional minutes, but fractional degrees, right? So you have to convert it to decimal degrees. And keep in mind that negative latitudes are south of the equator and negative longitudes are west of the prime meridian. So anything west of England is going to be a negative. We're a negative here on longitude. You can send it a grid square, a Maidenhead grid square, either 4-character or 6-character, and it will figure that out. You can send it. CWOP is something I don't remember if we ever actually talked about CWOP. It's the Citizens Weather Observer Program. And basically, lots of people have weather stations at their house. And what they can do is send that weather information to the National Weather Service, which will happily keep track of that and use it in their forecasting, which is awesome. Every Citizens Weather Observation Station has a name or an address, an ID. You can specify one of those and find, if you know what it is, and find out what the weather is wherever that station was. So kind of cool. You can send it an airport code, either the 4-character ICAO code or 3-character IATA code, and it will respond with the weather in METAR format. Or you can send it a zip code and it will figure out where that is in the US and send you the weather report for that location. When you ask it for a when, you can ask it for today, which is the default. You can ask it for tonight. You can ask it for tomorrow. You can ask it for tomorrow night. You can ask it for a day of the week, like Thursday or Tuesday, or like Tuesday night, you could say. And it understands the 3-letter abbreviations for the days. So if I was to ask it for Tuesday night, it'll try to give me the forecast for next Tuesday, right? It only goes out a week because that's really as good as the forecasts are going to be. And again, forecasting, they're pretty good about telling you what's happening right now. As far as what's going to happen tomorrow or, a week from now, they're maybe not so great, but it's what it is. And then with the what, you can specify, I want a brief weather report, or I want the full weather report, or I want the current weather report, which would be the same as like right now. Or you can ask for it in METAR format or CWOP format. If you're not familiar with METAR, that is an aviation term, and aviation uses a system called METAR to present weather information. We'll look at a couple so you can see what it looks like. And then CWOP again is the Citizens Weather Observer Program, and they have a particular format as well. So again, WXBot is for non-US stations or non-US locations, and so WXBot is for US locations, and WXYO is for non-US. One interesting thing though, if you're sending it an airport code, even the WXBot can handle any airport in the world. So it doesn't have to be a US airport. If you know the airport close to where you want to get the weather, you can use WXBot and get that. All right, let's play with it. All right, we're gonna open a message chat with WXBot. Somebody is pinging us like mad. What's going on over here? Getting a lot of traffic? No, I don't see a lot popping in over here. I don't know where that's coming from then. Somebody's being noisy. All right, so we're going to talk to WXBot. We're going to say, hey, what is the weather, the current weather? And it will come back and tell us the weather right now, as close as it can figure out to where we are. And I may not have actually sent a beacon, so it may not know where we are. We'll see if it says anything. Let me send a beacon if I can. I think this is the beacon. That should include my location. One thing I hate about non-Linux machines is that you can't do anything with a window unless it's in front. Yeah, so it's really annoying. So current apparently is not going to work for us. Let's try today. Maybe WXBot's not responding.
I can see you sending something out.
Not getting any replies back from it. Let's try something like 84123. Try our zip code here. Let's see if it can do something with that. Probably killed it the other day when I was playing around with it.
One message too many.
I don't know. Maybe I sent it something that I couldn't handle and it crashed. Right? Because you got to keep in mind, these services were written by hams, not necessarily professional software developers. And I don't know about you, but as a professional software developer, I know that even if it was written by a professional software developer, there's no guarantee that it's going to be actually any good at all. Right? So keep that in mind. But yeah, it looks like WXBot's not going to play tonight. So, oh well. That's unfortunate, but that's the way it is. Maybe we'll try him again in a little while. Okay. Let's go back to the next thing. So who has played with Summits on the Air? Dan, I know you have. I know Paul has. I know, yeah, Rick has for sure. He's done Parks on the Air too a lot. So SOTA is Summits on the Air. And basically what the idea here is people will take their radio and they'll go climb on top of a mountain and get up on the summit and set up their radio and try to make contacts. And if you can make 10 contacts, that's considered an activation of that summit. And you get prizes, you know, or recognition. I don't know. You might get a certificate, right? I guess that's a prize, but you get recognition for having done that. So there's actually a SOTA gateway where you can send a message to SOTA with your summit location, and this is the association and summit reference number. We'll dig into that in a minute. The frequency that you're monitoring, the mode that you're using, and optionally the call sign that you want to recognize there. And what happens when you do this is when you spot somebody, other people can see that that's happened, and so they'll quickly tune in and try to make contacts with them as well. There are a group of people called chasers whose goal is to talk to people who are sitting on summits for some reason. Maybe they have a guru fixation or something, and they figure, if you've climbed to the top of a high mountain, then you must know something. So I'll try to talk to you. But yeah, so with APRS, if I'm out there wandering around on top of a high mountain, maybe I don't have cell phone coverage there. Maybe I do, maybe I don't. But I can send an APRS message and let people know that I'm sitting on this summit, right? So an example message that I might send would be W7U, which is the Association for Utah, stroke UT-043, which in this case is View Benchmark, which is the official name of Alien Tower up on Traverse Ridge. And the frequency that I'm listening to, 146.54 simplex on FM, and the call sign, which is Paul's call sign here. When Paul did his activation of Alien Tower back in October, that would have been the message that he would have sent out. And that would have shown up on the SOTA Watch website, and people would have been able to see, oh, look, here's an activation. Somebody is over here on this mountain. I will try to reach out to them. He activated 2 meter, 70 centimeter, and 6 meter and 10 meter frequencies when he was up there, and was able to get, I forget how many contacts he said he had. He had something like 23 contacts or something like that. So he had a pretty good activation. But this is something that people do for fun, right? Personally, I can think of more fun things to do than to carry a bunch of radio equipment to the top of a mountain. But I guess I see the attraction. It's kind of a way to combine two hobbies, hiking and enjoying mountain views with amateur radio. And of course, we all know that amateur radio must be used for everything that you could possibly use it for. So of course, it's going to be used for that. There's another SOTA integration called SOTA to APRS. And what this does is actually watches the SOTA information and puts objects out on APRS to show where things are happening. When I was poking around with this Monday night, I actually found up at Grand Targhee up by Jackson Hole, there's a summit there, and it's W7Y for Wyoming, TT086. And there was a dude running APRS, presumably on his handheld, KD2UWR-7, out at the ski resort. And because he's fairly close to this summit, SOTA to APRS was saying, hey, I'm going to put this object out there and say, look, here's a summit close to you. So you can see that and you can go there. And so somebody who's watching him and thinking, well, I know he's going to do an activation from that summit in a little bit, I could watch and see as he gets closer to where that summit is. And when he gets there, I can make that first chase of him, right? So it's kind of a cool thing.
Hey, just so everybody knows, AI3W did a SOTA activation on 21.059 megahertz on Clayton Peak. You know where Clayton Peak is?
No idea.
Peak is like, let's get something close by Garfman Pass.
Oh, okay.
Big Cottonwood Road.
Cool. So when did you do that? Today?
Shows that he's still up there.
Nope. Well, he may be spending the night. Yeah. He may be spending the night. Anyway, so that's another integration with SOTA, is this SOTA to APRS thing. Now, that's the end of my presentation. I did find another thing. I was looking for something for POTA, for Parks on the Air, that does the same thing. And I found this thing. Let me pull it up real quick. I found this thing. I think it's in one of these windows. Maybe somewhere. Maybe not. Okay. Well, we're just gonna put it here. It's called AP. Well, let's do this. I'll find it. Coda to APRS. So this is what I was searching for. And I found this thing, AP Spot. And so what AP Spot tries to do is it tries to do everything. Oh, I guess it was that one. It was this one here. The idea being that you can send a message to AP Spot from your APRS device, and it will spot you and say, are you close to a summit? I'll spot you on SOTA. Are you close to a park? I'll spot you on parks on the air. Are you close to a beach? I'll spot you on beaches on the air. Are you close to some wildlife location? I'll spot you on parksandpeaks.org. It'll happily do all of those for you.
Sounds like an overeater.
Yes, I thought that too. And I thought, okay, I guess it's kind of cool. It's a one-stop shop, right? And he's happy to add more systems to AP Spot if you tell him how they work and there's an API for them. And so he says, let me know. And you know, it'd be awesome to just add some more stuff. So we'll take a look at his visual example here. And you can see he's got his Yaesu FT2D and he is sending a message to AP Spot. And he just says, hey, I'm here. And it's going to take the information that it knows and try to throw him out there on all of these different spotting type setups. Can't really read this very well because his screenshots are
Does it
pretty
use the
pretty terrible.
GPS function of the 2D where you can point
My
there?
my suspicion is that you have to have beaconed a position so that it knows where you are, and you have to have beaconed your frequency, your operating frequency.
The 2D knows where he is anyway, because he has a GPS.
But it has to be included in the APRS message.
Yeah, and I think they are, they
It should be.
should be.
It should be by default, right?
Yeah.
So yes, it should have used that information directly from that. Devices that have APRS built in, obviously the Kenwood D7, D72, D74, those are the premier APRS capable handhelds. The Kenwood D700 and D710 are the mobiles. Yaesu has a bunch of radios that have APRS functionality. They don't have generic packet functionality, but they do have pretty good APRS functionality. I know Dan's got a couple of Yaesu radios that do this. I know Gordon has a couple that'll do this. The DMR radios, like the Anytone 858, has this functionality, APRS bidirectional functionality built into it. Both APRS over DMR and directly over the regular APRS frequency analog. There's a protocol that's called DPRS that D-Star radios have that can bidirectionally communicate with APRS. So if you have that set up on your D-Star radio and you can hit a D-Star repeater, then you can do it that way. There's lots of different ways to get involved with APRS. Watch that previous presentation. We talked a lot about what hardware you need to get involved with APRS and how to set it up and how it works and all that kind of stuff. Definitely worth spending your time watching that. But in general, that's APRS and what you can do with it. So
Yeah, I'm optimistic and hopeful that we'll see a little more inclusion of APRS stuff and cheaper integrated radios, especially as like APRS messaging is coming to GMRS simplex now.
is it APRS messaging or is it some GPRS bastardization of APRS?
It's without any distributing or iGates or anything. It uses the AFS stuff.
Because I remember when GMRS was first coming out with this stuff, there was a product called the Rhino, that was a GMRS radio
Yeah.
that
but
could-
Garmin.
that, yeah, it was made by Garmin, right? And it could do that position reporting. And they actually had to have a special FCC waiver to be able to send digital information over GMRS, because at the time it was not legal to do that. They have relaxed that rule now, and they are allowing digital information to be sent over GMRS. So I don't know that it's compatible with APRS.
Oh, I saw Reddit, and if it was on Reddit.
It must be true, right? Yeah, so.
I saw a Reddit thing about some guy communicating with his, I guess it's a VTech GMRS Pro handheld. And he said he was decoding those things exactly with his APRS.
Okay, cool.
So it's like, presumably, there, at least some of the radios are starting to do that.
Cool. So maybe APRS will make a comeback and start to get more popular again. I'm going to go ahead and pull up APRS.fi. So this is the thing that you were talking about, Neil, right? And so one of the things you see on here, all these WX guys, these are all those CWOP stations, right? So you could we could have tested that if WXBot was working. We could have sent it one of these like DW6120, and it would have given us his weather information. APRS.fi tries to actually decode all of this stuff and present it in a very nice fashion. This is run by a guy named Hesu, who is in Finland, hence the .fi, and he is happy to collect this information all worldwide and present it through a pretty nice little web interface. But you can see, let me turn on we turn on APRS stations. I need to turn off. Where is it? Stations. Station type. Where is it? I wanted to strip out. I have actually, am I not logged in? Maybe I'm not logged in. I thought I had a filter, defined filter. Oh, here we go. So I have an APRS only filter, and that'll get rid of all those weather stations, and you can see what's actually out there right now here in Salt Lake. So we got KK7OW is driving around in his truck. We've got N7LCR. I think I know that guy. That's Ragnar. I don't know why I guess that's his house. And you can just see there's mine right there, KD7ZWB-1. That's my Yak station that's running right now.
So look at the person right above that.
N7XDL. That's Dan on his handheld, right? On his FT. So if you look at like this, we'll pull up the info, and you can see this is that path that we were talking about. So it started at N7XDL-5. It was sent, so the packet radio destination was APDR16, which is the code for your radio type.
So this is on my Android.
So it's your Android. So that's probably what the DR is, DR16. And then it came in via TCP, so it didn't ever hit the RF, right?
Correct.
Let's go look at one of these guys that's on RF, like this guy. We'll look at his info. So you can see his path, KK7, CVP-9. It's sent to TOSRRQ. So that's some kind of little tracker. And it was sent to wide 1-1, wide 2- presumably 2, and was digipeated once by KB7STN-3. So he's using a much broader path than he probably needs to.
That's what this is what that was set up for.
Oh, by the default was like that?
I looked at the path.
but then it shows like stations that are close to him, stations which have heard him directly. So all of these digipeaters have heard him directly. So obviously he doesn't need to use a 3-hop digipeater path, but maybe he goes places where he does need that. I don't know. Report him to who? Obviously. The men in white coats, yes. Go get him. So Logan actually has quite a bit of activity. And you can see one of the things that they do, if I can zoom in here. You can see, oh, I don't have the objects showing. Let me see if I can turn that on. I want, oh, I should be seeing objects. I don't want to cancel. I want to add. Let's see if we can go to. Let's just go to the default list. How do I clear this? There we go. Okay. So you'll see some weather stations out here, and there should be an object for the repeater up there. I don't see it on there anymore either. Let's go somewhere. One of the things that it does is as you zoom out and there's too much information to see, it gives you kind of this heat map that shows where the activity is. So if we cruise out here to the East Coast area, let's drop into, yeah, it's pretty popular over there, right? Let me switch back to that APRS only to get those weather stations off. So you can see all these different stations out here.
Is it H a hospital?
Yeah, H I think is, yeah, it's a hospital. Capital Regional Medical Center.
Which state is it?
This is Maryland. So you can see like each one of these stations has like a different symbol. So like here's one with a little dude walking, right? So that's somebody with their handheld, like yours, right? So his is actually KO4IJH in Alexandria, Virginia. Theoretically, we could send him a message and see if he responded, but probably won't do that. But you can see, if we look at his, he's got an Anytone ATD 878, so he's using that DMR gateway. So that's kind of cool. Oh, it jumped me all the way back home.
Let me see if there's anything coming out of Biden's house.
Delaware. Oh, here's a repeater object up on Antelope Island, or no, this is Promontory. 147.26. And it shows you the frequency, the tone, and then it says there's a net on Tuesdays at 9 p.m. on that repeater. So we should publish an object for our nets and things like that as well, and for our repeater as well. One thing that you can do with these objects as you receive them, if you've got an APRS handheld, like the D74 will do it, and I know I've got the D72 and it'll do it, you can actually click a button on your view of that object and your radio will tune to that frequency, tone, and everything automatically for you, because the frequency is included in the message, right? So pretty cool feature. So this was originally published by W7BOZ-1, and he's the guy who's been putting that out. But there should be, I mean, we've got a ton of repeaters around this area.
Right there. Go to your right.
Right here. 147, 200. K7 SDC star point. So, I have no idea. On the boonies.
So Ragnar raises now.
Oh, Ragnar, you need to say something to us. Let me see if I can unmute.
Okay,
Go back to my Zoom. Oh, here we go. I think I just need to turn my speaker on.
am I
Say
there?
something, Ragnar.
Am I there yet? Hello?
Nope, we can't hear you.
You can't?
well.
Okay.
Anyway, that's about all I got for tonight, guys. So I'm gonna go ahead and stop the recording somewhere on here.